Un, deux, un, deux, un, deux. C'est tout bon? Ouais, c'est bon. Pour le micro, c'est bon?
Pour le micro, ce micro-là, c'est
ouais. Ce micro s'est enregistré et celui-là sert à parler, simplement? Donc je reste devant celui-là?
Non, non, c'est...
1, 2, 1, 2. C'est super. Okay. Donc tout le monde entend dans la salle là?
Non. Par contre, tu peux utiliser le micro. T'en as deux.
J'en ai deux.
Si tu codes, celui-là, si tu bouges.
Non, celui-là, je ne vais pas bouger, du coup, je vais rester là.
Mais il est branché tout ça.
Mais tu vas me le mettre dans la gueule?
Oh! Il marche pas, il n'est pas allumé. Attends, c'est le numéro combien?
Pardon?
Il y a juste un petit bruit bizarre.
Mais lui, il marche pas en fait, il est éteint.
Je pense que c'est
bah, change-le.
C'est peut-être celui-là qui... Oh putain, ils m'ont cassé mon VGA.
Et le petit... t'as allumé les petits...
Comment?
Tu l'as allumé? Ouais, c'est bon.
Oh!
Ouais. Bah, ça a marché jusqu'à ce qu'on touche à tous les câbles. Oh. Ah ouais, vous n'avez pas changé la source du... Qu'est-ce que vous m'avez fait? Ça marchait. PC conf, non? Parce que PC jardin, non, assez court. Ok. On est parti? Is this working? Yes. All right. Hi everyone, I'm JB. I'm tasked with the difficult task to present just before lunch, when just everyone is tired, is hungry, and wants to get away with this. So this talk should hopefully be light and funny, but also deeply technical. So, yeah, and I thought I was being funny and cute by doing an unwritten presentation, and Rob just beat me to it, so this is very, very sad. So I'm JB, I'm the founder of a small company, Syntax Tree, which is sponsoring this event. We're doing developer tools, and I have a very long background in the .NET open source community. I worked on Mono, the open source .NET implementation, for years. Yeah, I'm a programming language geek. I love compilers, and obviously what's this? It's a box.
Black box.
Not only it's a box, but it's black. It's indeed a black box. It's a black box with a function. It has input, it takes input, and it takes output. And it gives back an output. This black box is your compiler. You feed it C# sources, and hopefully it will give you back an executable. Most of the time it will give you back errors though. So yeah, everything I say today applies to both C# and VB.NET, but is anyone here doing VB.NET? My point exactly. So we'll be talking only about C# today. So this is your C# compiler. It takes sources, it's csc.exe, and it gives you back an executable. But remember what Reese said this morning. We're hackers. We want to learn how things work. Just like Brad Pitt, you want to know what's in the box. And that makes Anders laugh, right? Anders is the creator of C#, and currently the C# team at Microsoft is the only one who has insight on what's inside the box. Except that other people needed it. So for instance, the Visual Studio team for the C# integration needed to have access to the internals of the C# compiler. So at some point, they had to take a snapshot of the C# compiler and adjust it for parsing C# into Visual Studio. And as it turns out, they ended up having two different implementations, right? But outside of Microsoft, no one. Let's spend some more time talking about this box. So the C# compiler, you've been using it ever since you wrote your first line of C#. It's been here since C#1. It's very fast. If you compare like the typical compilation cycle of C# compared to C++, you love your C#. Again, it's very fast. It's better tested. I don't know if any of you ever found a bug in the C# compiler. I did once. Whoa. What was that? All right. All right. Yes, not surprising. All right. But yeah, like, so it works, and it has been working for years. So why would you want to look inside the box? What usage would you have? Is there a point in opening this box? If you look around outside of the C# community, in some more exotic language in Java, or even on C++ with LLVM and CLang, having open compilers really triggered a whole new range of innovations. And well, Microsoft thinks that there is a point in opening this box. So what they did is that Roslyn is their brand new C# and VB.NET compiler that they've been working on for, I think, 4 to 5 years now. So it's a really long time. And they opened it in two ways. The first one is that they opened it in terms of open source. Roslyn is open source. You can get it on Codeplex. The license is Apache 2, which means that you can use Roslyn code into your commercial application. And the second way they opened this compiler is that the entire compiler architecture is open. You have access to a whole range of API to target almost everything in the compiler. And we'll see how that's useful. Let's talk a bit about how compilers work. Any of you wrote a compiler? Well, all right. So it's good that we do a short view of how a compiler works. We'll mainly focus on two stages. The first one is taking your sources as text, a representation of your program for the compiler. It's done in two phases. The lexing, which takes the text and splits every token, which like identifiers, number, parentheses, and try to find patterns in those tokens to find, oh, this is an addition. This is a class declaration. So that's what an AST is. And the second phase is pure magic. It takes an AST and hopefully it will give you back either errors or your program. And because this is plain magic, we won't talk much about it today. So we'll mainly focus on what happens with this AST, this syntax tree. Let's see, #2 is a 32-bit integer. You know that foo equals 2 will return a Boolean. You know that equal is an identity check between two reference or value check between value types. You also know that if the instance of foo declares its own equal equal, it could be a method call to a custom operator. That's the semantic. Again, it's different from the syntax, which is just an expression of the text that the compiler can look at. And Roslyn, we'll see about it, provides both things. It gives you your syntax tree, and you can query Roslyn to give you the semantic attached to the syntax tree. And that's really powerful, because when you have both, you have knowledge of the end of everything in your source code. You can do everything, such as refactoring or diagnostics. And Roslyn is an AST, a syntax tree, with my new node. And all I had to do for the last stage was, in the magic part of Roslyn, was to create a type, an actual type, when Roslyn binds node to actual types, where I'm saying, oh, this enumerable node is a simple construction of enumerable with its element type. And it's as simple as that. So yeah, working with Roslyn turns out to be very simple. I am not convinced, though, that everyone should go ahead and do that. And yeah, I'm not convinced that everyone should maintain their own version of the C# compiler with their own preferred syntax for things. But it's a fun exercise, and it gives you insight into how simple it is to approach Roslyn if you already know C#, the language. So yeah, Roslyn is definitely an advantage for the C# team. It's also a really good tool for people, right? You can create your own refactoring. You can create your own diagnostic. If you're using ReSharper, like ReSharper has this ability to give you like squiggly lines where it says, oh, you could do that differently, or you could transform this piece of code into something else. And when using Roslyn, you can do exactly that. And you could write your own refactoring and sell them. And even though JetBrains says that they're not afraid of Roslyn, I think they are. Because everyone will be able, quite simply, to augment their C# programming experience. But that's all right. I still love ReSharper. I actually can't live without it. And I think they're sponsored. But yeah, I can't write C# without ReSharper. So I don't see why we couldn't have a word with the two of them live and work together. Another example is UnityVS. UnityVS is a product that my company does. It's a Visual Studio plugin. Yeah, thinking about Roslyn could be used for everyone else. And I came up with a few different ideas. The principal thing, when you think about it, is that for all of us, C# is our lowest common denominator. We all write C#. And most of all, so let's spend 5 minutes thinking about what the future could look like when Roslyn will be widely available and will be truly a central and core part of .NET. What I think would be very nice in the future if, and we saw it with Cecil, I want to ship Cecil, but also ship diagnostic to help people using it. And one way to do it would be using Nugget. Nugget is really growing. There are more and more assemblies shipped with Nugget. And in the future, you can imagine that when you're shipping binaries with Nugget, you could also ship rules and diagnostics to help people use your libraries. In the future, like you can even think about powerful tools like migrating APIs. Imagine you have 3 versions of a Nugget package. In the first one, you ship something that was broken. In the second one, you put obsolete tags on methods. And on the third one, you remove the obsolete method. But if you had a consumer that didn't update to the new ways and is still using the obsolete members, what happens? Well, it will break. So in the future, you can imagine that you could write code fixes that you ship with your libraries so that you help people migrate directly to the new version of your APIs. And in the future, it's easy to imagine that at some point, you will also have the ability to have code that participate in the compilation process. Imagine that you could have some form of aspect-oriented programming where you put attributes on types, and you say, oh, here is a new step in the compiler that turns this attribute into code. It's already possible to do it right now with by manipulating the binaries with CCL. But you lose information when you translate something from IL back to a language. So you could say, oh, this class should implement iNotify property change. And in the future, maybe you'll have the ability to say, oh, this step, using the Roslyn API, will implement iNotify property change for all the properties. So I think that's really something where we're going towards. But currently, you already have a very powerful tool to help your users and to help yourself analyze and modify code. Thank you very much. Any question? Yes?
In terms of development life cycle, how does it to implement such Roslyn behaviors? Because with ReSharper, when you try to implement a plugin, it's a mess. You can't do TDD, you can't test it easily.
Yes. This is actually very simple. It's all interface-based, so you can test it very easily. You can even reuse the pieces of the testing frameworks that Roslyn itself uses to test itself. So yeah, it's all interface-based, and it's very easy to test. Currently, all you have to do is to implement one interface, and you can feed it code, and you can assert that, well, a diagnostic has been found. You can mock whatever you pass to the interface. So yes, that's actually very easy. A lot easier than writing ReSharper plugins anyway. And if you want to write a simple one, as I said, it's as simple as starting a new project, because there's like a project template for diagnostics, and you get the class for the diagnostic and for the fix, and all you have to do is to fill in the blank.
So you can test them without being an integration test within the IDE?
Yes. Yes. Anything else? As I said, we'll put all this code online so you can test it yourself. Thank you very much, and have a good lunch.
T'as eu des infos pour ce qu'ils vont le faire pour pouvoir shipper les diagnostics en nuggets? C'est vraiment...
Alors ça, c'est un esprit d'imagination, c'est un exercice d'imagination. On va un peu parler sur cet aspect-là. Je pense que c'est quelque chose vers lequel on va. C'est quelque chose qu'ils ont un petit peu dit à la build. Je pense que c'est vraiment quelque chose vers lequel on va, parce que c'est vraiment génial. On écrit du code et on peut aider les gens à l'utiliser. Enfin, pour plein d'aspects, ça peut avoir plein d'applications. Ou sur un framework ouais, web, ou bah non, enfin, ça tu devrais peut-être le faire comme ça. Ou alors, aider les gens par exemple à faire du code plus asynchrone. Dire bah ça.